Hi guys, I'm back to talk about the last climate change installment. So this is a little bit about kind of the human relationship with climate change. So I'm gonna share my screen. Here we go, share. Okay, climate change part 3. Okay, so we know that the climate is changing rapidly. We know that this has impacts on ice cover, on sea level, on extreme events, on precipitation, on the distribution of species on the planet, biodiversity, et cetera, et cetera. And the more that we understand and the more we are becoming really observant of these events in action. So like in the last decade, we've seen a lot more kind of climate change related natural disasters and impacts. We are beginning to understand that it is so necessary for us to try to change the emissions scenario that we will be living in the future in order to hope to change the rate of climate warming. So in the past, there was lots of discussion about, climate change would be too bad, but trying to decarbonize our economy and other things like this would be too costly to our economy. And so it is not possible, or it is not worth it for us to kind of make a compromise to reduce carbon emissions just to save some species. But now, as we again are observing these massive wildfires and hurricane incidents increasing, and observing sea level rise, and observing the movement that's required by climate refugees, people that can no longer live in the places where they previously were able to live, we're noticing that there are huge economic, social, and political impacts to doing nothing. The doing nothing scenario is becoming less and less appealing. And the cost of climate change is just becoming too great for us to ignore. So a couple of different statistics by some different studies by like the Pew Trust or the Stern Group out of Britain say the cost of loss to ecosystem services, these jobs that the ecosystem currently does for us, like flood mitigation or pollination, the loss of these kinds of services in a warmer climate would cost somewhere between $5 and $90 trillion by the end of the century. So that's a big number. And these shifts in our global climate would impact our global GDP by costing us somewhere between 5 to 20% of our global GDP. On the other hand, one of these same studies looked at what are the costs that would be required to adapt our economies to the world of climate change. So both what is the cost of kind of getting us off carbon, and also what is the cost of kind of trying to transform our infrastructures and our communities to be more resilient in the face of some climate change, which is inevitable. And while those expenses are high, they're much less high than the cost that we think we'll experience if we try to ignore this problem further. So the range in this particular study by the Stern Group showed that the cost would be about 1% of global GDP, which is a big number, but it's much smaller than 5 to 20% of our global GDP, or gross domestic product. Okay, so we know that there is this correlation between greenhouse gases and temperature changing. We know that one of the sources of greenhouse gases to our atmosphere is the burning of fossil fuels. So fossil fuels are these fuels that we dig up from the ground. They're old carbon compounds that used to be part of living organisms millions of years ago. We dig them up and we burn them, just like we also can burn living organisms that are alive today to capture energy, right? Like wood on a campfire. But we're burning these old living organisms that have kind of concentrated carbon bonds in them and can release lots of energy. And unfortunately, as we look at this trend in millions of tons of carbon dioxide per year that are released as a result of human activity, and then the cumulative additional CO2 concentrations as a fraction over time, we see that there's a couple different sectors that have really big impact. So one change is land use change, like cutting down forests or removing natural grasslands to put in agricultural systems, create systems that are less good at absorbing carbon than their native vegetation system. So some of that's inevitable, but it's something to be aware of. That is something that is changing. That's the land use component that's shown in blue. The burning of coal, which is primarily done for electricity production, is a big contributor, and that's something that has been steadily increasing since the Industrial Revolution. The burning of oil, so that's like what we put in our gas tank when we go to the car, or when we go to the gas station to drive our cars. And then the gas that's not the gasoline that we put in our cars, that's the natural gas that we use for electricity production in some cases, transportation in some small cases, but also for things like natural gas that we use in our homes for like our stove or our water heater. And then cement production is a big releaser of carbon to the atmosphere as well. So when we grind up limestone to create cement, that's a big polluter as well. So anyway, we can see that there's this very clear correlation between the use of these fossil fuels and the buildup of carbon dioxide in the atmosphere. We know that there's this very clear connection between carbon dioxide in the atmosphere and other greenhouse gases and temperature change. And so this is one of the ways that we understand this connection. So how can we combat this? Well, first of all, kind of international policies. So there have been a series of international treaties and protocols that have been put in place trying to address climate. So going back to the 1990s, there was something that was called the Kyoto Protocol, which was kind of an acknowledgement of this problem, and then this international treaty that countries were supposed to sign into, where they were having these voluntary targets to try to reduce their carbon emissions. The US actually never ended up ratifying this treaty, so it kind of abandoned this goal, which is a problem since we are a big contributor to global carbon and a big part of the global population. So then more recently, in 2016, there was a big conference in Paris, and countries around the world came to what is called the Paris Agreement. And this particular agreement plans to limit temperature increase to 2 degrees above pre-industrial temperatures. So going back to the early 1800s, looking at the temperature then, we're going to try to limit it to 2 degrees Celsius increase over that point. And then it had hopes that we could limit it even more than that to 1.5 degrees Celsius. And again, remembering back to our graphs that we looked at from the IPCC in the last lecture, we said in a best case scenario trajectory, we are looking at a 1 degree Celsius increase over today, where we've already seen nearly a 1 degree Celsius increase over the pre-industrial era. So basically, this would be really a very best case optimistic scenario. However, a lot of people that are looking at the cost of climate change are saying that we really need to work hard to try to meet this, because the costs of ignoring the problem are just going to be too great. So the Paris Agreement had kind of a 3-pronged approach. It had this 20-20-20 targets. So it hoped to reduce CO2 emissions from these different countries, and then collectively globally by 20%, tried to increase the use of renewable energy sources by 20%, and then tried to increase energy use efficiency by 20%. And it hoped that these 3 goals, working collectively with all places around the world, so not just Europe, not just the United States, but working with China, working with India, working with Brazil, working with the industrializing world, that we would hope to really curtail our emissions and then be able to keep our climate change in check. So not stop it. There's already too much carbon in the atmosphere to expect that we're going to stop our warming by the end of the century, but kind of slow the rate, flatten the curve, you could say, of what that climate change is going to look like. So with the change in the administration from the Obama administration to the Trump administration, our federal government has backed out of trying to meet these particular agreements. So many people that work in climate are frustrated and concerned about this. They think this is an oversight, but that's the political situation that we're in. While the federal government has not decided to take decisive action on this issue, many state and local governments are working harder to make changes, both to try to reduce carbon emissions, increase renewable energy use, and then also just try to make their communities more adaptive to what we know will certainly be a warming climate. And so, this might be a whole range of things like stations for electric vehicle charging, or it might be different kinds of tax, or business incentives to reducing carbon emissions, and it might be also things like thinning forests to try to reduce wildfire risk, or creating hurricane relief plans. So it's kind of a combined effort, but in this stage at the United States, this is very much being driven at a local and state level, since the federal government and this particular administration has been very hands-off. Okay, so what else do we need to do to address this climate problem? Well, it's big. So I think many people kind of understand that it's this looming problem, but don't really understand how we can realistically try to tackle it. And so they'd rather kind of ignore it than try to think about how to address it. And so one particular approach was put forward by a professor named Sokolow, and he has been kind of widely noted for this particular approach, and this is called the Wedge Approach. And so basically in the upper graph, what we can see is that as we're moving forward, we are on this change in our temperature that's related to a change in the increase in carbon that we're introducing to the atmosphere. And our goal as a society is to kind of flatten this curve, take away the steep rate of increase. And so one thing alone is not going to be enough to make this big ship turn around, right? It's like the Titanic. It can't turn on a dime. Okay, so instead of just trying to come up with kind of like one magic solution, what he said is we should kind of look at this wedge, and then we should think about many, many different kinds of solutions that can all kind of stack together. And each one can reduce our carbon emissions by a little bit. And then overall, hopefully, we'll start to kind of see the flattening of the curve that we're hoping for. So some of the strategies that he wrote about were electricity efficiency, other kinds of efficiencies, passenger vehicle efficiency, other transport efficiency, so like planes or public transportation, use of renewables to produce our energy system, et cetera, et cetera. So, right, it's not like a one-shot deal. We have to make many coordinated efforts throughout our society, using technological advances throughout our economy, and not just in one country, but as a global community to try to address this problem. And again, if we don't, the costs are projected to be very, very high, both in terms of human displacement, in terms of loss of life, but also just in terms of kind of monetary costs. So we certainly need to make investments in clean energy. And we're going to talk about energy more in environmental science. So I'm not going to get into this a lot now, but improving technological efficiency of certain things like solar and wind, geothermal, and then creating incentives for people to move away from fossil fuels into these industries is what's recommended. So that's one thing to consider. And then also perhaps taking advantage of different kinds of carbon technologies. So there's certain kinds of what are called carbon capture technologies, where we try to go to the places where carbon emissions are being created and then capture that carbon before it's released into the atmosphere. And then normally what's done is that then that carbon is injected down into the ground. So stored in rock or groundwater deep below the ground. So that's kind of one strategy, keep the carbon out of the atmosphere by putting it underground instead. Sometimes this is done in coordination with a fracking process. So some of the carbon is actually used to do the fracking process, but it's not always. So anyway, this is a form of carbon capture. And then there's other kinds of geoengineering ideas that have been proposed. Many are controversial, but certain things are like maybe we could put more sulfur ions out in the stratosphere, up in the upper atmosphere, to reflect more sunlight. So we'd be getting less energy to our planet, and that would help slow the rate of global warming. So there's some concern about unintended consequences associated with many of these things that we may not understand yet. But these are ideas that are certainly being proposed, explored, and tried out as well. Okay, so this is one of the biggest issues of our generation that we are faced with tackling, and the decisions that we make are going to have big impacts on our life and our society in the future.